Okay, so now that we've took a look at the importance of the concatenation of the transform node, what I want to show you now is that this principle also apply in the 3D system of Nuke. So what I'll show you is that by just changing the way you connect your projection inside of Nuke, you can really destroy the quality of the texture you're projecting depending on the way that you connect your node. So for this example, we'll just pretend that we want to replace the three picture in those frame here. So that will replace them by doing a projection in each one of them. So you'll see that by just changing the way we connect the image, we'll have a different quality. So let's first start by tracking this plate here. So I'll just make a new camera tracker and connect it to our plate. So I'm not going to spend too much time on the tracking of this plate. What I want to show you is not how you to 3D track this and how you should do it. I just want to show you the projection part. So I'll just change real fast maybe the setting to have more features. I'll put something like 300 since there's not much to track, so we'll make sure that we have enough tracks. So I'm not going to take care of the lens distortion, which is something that normally I would do. So I just hit track and let this plate track. Okay, so now that the tracking has finished, we'll solve this camera. So just hit solve. And let's take a look at the result that this tracking is giving. So we have an error of 2.19, which is a bit high for the HD resolution. But like I said, the intention of this training is not to have the perfect track. So of course, by using the lens distortion, by removing the distortion, we will have a better result since this is a pretty wide lens. So we have our tracking here. So we'll just create the camera of the shot. So create. And we'll also put a card for the wall here. So we'll just also make a point cloud so that we see how those points are in 3D. So we'll hit create and we'll put this in the scene. So we'll connect our camera as well as the point cloud here. And we'll also make a new card that will also put in the scene. That. So if we take a look at our card, we see that there's some points that are off, but we can see that for the three image we have pretty good point that we can put our card on those positions. So we'll just move the card in this position, scale it a bit, and this should be good enough for this example. So let's say that we want to change the three image, so we'll just make a checkerboard from one of the image, and let's say a color bar for the other one, so color bar, and then we'll also reuse the color bar for the third image here. So since all those images are on the same plane, the easy way would be to place this in 2D over our projecting frame that we want to use and just place them in 2D and project those three pictures on the same card, since we don't need to make three different cards. So we'll go at the frame one. So let's say this is the frame we want to project on. So I'll just make a corner pin to put this over our plate. So we'll make corner pin and we'll put this over the plate so we have a visual representation of how we're placing the image. So we'll just place this over our center frame here. So something like that. And as well at this corner here. And like that. So let's say that for this one we're good. Then we'll just duplicate this corner pin, connect the merge to this corner pin so that we can place this image. Then we'll move it on the left here. Just refine some of the corner. That. And we'll do the same thing for the other image. Just take this and move it here. Okay, so let's say that we're all set. So now, since we know that those 3 images are on the right place on this frame here, now what we can do is merge all those textures together. Like this. And now we can project this into our card. So now what we can do is take our card and do a project 3D. And what we want to project is this texture that we just made. And we want to project using the camera that we've made. So we'll use this. And since we are projecting on frame 1, we'll make sure to put a frame hold so that will freeze the camera as well as the texture. So just make sure to use your projecting frame. And then we'll connect this in our card. Then we'll call a scanline render to render our projection. So we'll connect the card to our scene, use the camera to film the scene, and just to make sure that we render in the right resolution, we're going to put a reformat in HD here, like that. So now just to test this, we'll put our result over the original plate and take a look at the kind of quality that we have. So we'll just do a quick flipbook of this render and we'll see the kind of resolution that we have in the center frame at the end of the shot where the frame is the closest possible to the camera. So we have our frame in the right place. And now if we pause this to the last frame and just zoom a bit on the quality that we have on this picture here, you see that we have a lot of blurriness in this image. And let's just take our project 3D here, and instead we'll connect the texture from the corner pin directly inside the project 3D and take a look at the texture quality that will be changing. So by just connecting it directly to the corner pin, you see that we've gained a lot of quality in the texture here. So again, if I connect this to our merge here, you see that all the texture are soft. And even if we take a look at the texture here on the left, you see that we have some blurriness. And if we connect this directly to the corner pin, we've gained a lot of sharpness. And the reason for that is that, like I was saying, the concatenation also followed the 3D system. But now what we're doing when merging all those textures is that we're taking this HD texture, then we corner pin it in a smaller size here, but then we merge it with another texture that is also being reduced. So now what happened when we merge those two together is pretty much like when we put a blur between two transform nodes. This is now considered a rendered texture with this resolution. So now when we connect this in the card and that the camera is getting really close to the frame, then our rendered texture is missing a lot of resolution. But if you connect the project 3D directly to the corner pin, since we're not breaking the transform from the corner pin to the project 3D, Nukes knows that this texture has a lot of resolution and won't break the original resolution through all the projection setup. So now the resolution quality that this card is receiving is much higher than when we bake the projection in the merge here. So the trick is to, from your texture to the project 3D, keep as much as quality as possible by not transforming your texture and breaking it before the project 3D. So the first way to fix this, of course, would be to do 3 different skyline renders. So you would put this texture with this corner pin and then project it directly on the card and render it with the camera and do the same thing for this texture as well as this one. But that would involve 3 different skyline render, which is a waste of time and CPU. So the better way is to use the merge mat that will allow us to do this kind of setup here while maintaining the texture quality. So with the merge mat, we'll be able to do a projection on just one single card and using a single skyline render. So let's modify the setup so that we can use the merge mat. So we'll go back at frame 1 and we'll just disconnect those 2 merge here. And what we'll do is that we'll connect our first project 3D here to our corner pin. And then we have our frame hold that is frame holding the camera. Then what we'll do is we'll make another project 3D, connect it to our other texture, and we'll also use the same camera for the projection. So we'll connect this here, and we'll also make sure to frame hold our camera. Then we'll duplicate it again, connect our third texture, and connect the camera as well as frame holding the projection. Now what we'll do, instead of merging the texture in 2D, is that we'll merge them in 3D using the merge mat. So we'll call the merge mat node, and now what we'll do is we'll put in 3D this projection setup over this one. And then we'll duplicate our merge mat and take this projection setup texture over our last project 3D here. So now what we'll be connecting in the card is this merge mat here. So now if we connect the merge mat in the card, we see that we have gained the same result that we had. But now let's take a look at the difference in quality that we have in our texture. So we'll put this over our original plate. We'll press play, so we see that we have the same tracking result. But now if we go at the end here and zoom on the texture, we see that we have lost no quality, unlike what we had with the merge node. So if you see, I take my card and connect it directly to the project 3D here, to the frame hole here, you see that between this and this, there is no quality loss. So the trick is to, like I said, use the merge mat to merge multiple projection on the same geometry. So this has the benefit of using a single geometry as well as a single scanline render node. So in another training, I'll also be showing you how the merge mat give you the best of both worlds when you need to project different thing on a single geometry, but at a different place on the geometry. So we'll see how this merge mat is also helpful when you need to do multiple projection on the different faces of the same geometry.